Equipment, it's difficult. Welcome to the TapRooT Podcast. Today I'm joined by Ken Reed and Justin Clark, and we're going to be talking about the difficulties when collecting equipment evidence. So we're going to jump right into it with the first question, which is what makes collecting equipment evidence difficult? What's the challenge that people have that you've seen when collecting evidence for equipment failures?
I think one of the things that I've noticed is that sometimes investigators don't even realize it's an equipment issue because a lot of the investigations that we see, some large percentage, are HSE kind of problems or quality problems. They are operational types issues. And this little piece over here says the equipment failed. Oh, and look at all the problems we had. We focus over here. And we kind of let this equipment issue kind of stay off on the side. So that's one of the issues that I see with collecting the data for an equipment failure.
And a lot of the times the first thing we see is the equipment fails in an accident, and then all of the mistakes humans make after that kind of compound the issue or just don't respond as they should. But then we come with a regular process safety regulator comes in and investigates the incident and does their own external. They kind of leave the equipment troubleshooting off to the side, but that's a piece that started the incident, and so they do all the process safety, they do all the equipment or the human response to it, all of the operator open the wrong valve type of things, but the equipment failure itself is just kind of left out there as something that happened that doesn't even get touched a lot of times. Yeah. So we know that a pump seized and then everything else happened, and that whole pump seizure is really important to investigate because that's usually what we see as the starting event for a lot of incidents, the place where the system really became unstable.
Yeah, I also see sometimes the equipment failure is going to be usually investigated by some equipment guy, right? It's not the HSE guy, it's not the quality guy, it's some equipment troubleshooter guy, whether he's the maintenance guy or the reliability person in charge. And when they start doing those investigations, they think it's a different kind of investigation. It's, it broke, let's investigate how to fix it. And it's not necessarily, it broke, how do we investigate how to prevent it from breaking again? Mm-hmm. And those are kind of two separate thoughts sometimes. And I think we focus too much on it broke, it's got a bad bearing, corrective action, put a new bearing in it, and we've fixed the problem. And that's where equipment troubleshooting sometimes goes off on the side, and it's not actually looking at the things that we need to take a look at. So when we say equipment troubleshooting, it's holistically, it's a bigger piece of not just the equipment itself, but the whole operational piece, the whole problem that came up because of the equipment failure, sometimes skipped over.
To me, I think there's kind of two sides to this. There's the inexperience of the person collecting evidence, and there is also this idea of what are we trying to investigate. So, you mentioned this being kind of an HSE investigation. A lot of times they're looking at just, what harmed? And so they'll focus in on the human aspect of it.
Right. Yep.
And they don't start where, Justin, you mentioned it started with an equipment failure. Well, the equipment was just going to fail. And we responded poorly, and that was what we need to investigate. That's is how we responded poorly. But if you really go and say, hey, what started this? Well, if this equipment never failed, this incident never happened. So I think there is some that people just don't focus, but I think a lot of that is because they're not comfortable asking the right questions for equipment failures.
Yeah, oftentimes they don't know where to start with an equipment failure. Even equipment experts sometimes They go as far as they can. So they had a bearing failure, and they've seen a bearing failure 10 times or 100 times in their career. So they automatically focus on, I know where the problem is. It's the last time I saw this, it was this, and last time I saw it was that again. So it must be the same problem. And they don't know how to get outside their own experience level a lot of times, where to go look beyond, this is what I've seen in my career. And that's where they get hung up. So when they can't find that problem that they're used to in their career, now they're stuck. It's like, well, darn it, I just checked everything I can think of. Now where do I go? And they get kind of stuck with those kind of roadblocks.
So to me, there's a couple things. Whenever I see an equipment failure, I want to start collecting evidence on certain things, and I think when we look for what happened, there's two sides. We want to, one, isolate what physically caused that failure. So what was it about this that actually broke? Was it the bearing, or was it something else that led to that bearing failure?
Right.
So I think there's one aspect there that as investigators we have to really define what exactly failed, and the other is I want to start collecting evidence about that piece of equipment. The history, the PMs, when it was installed, how long it's been run. There's all these, pieces of information, and at the beginning of an equipment investigation, you have no idea where it's going to lead.
Yep.
It could be any number of those things.
Exactly.
And that could be really intimidating, because if you're not an expert in that piece of equipment, having that list of things to start checking off, well, yeah, okay, I'm going to get the history, but I don't know what any of that means.
Right. Yeah. So I think you've, in my mind also, most equipment troubleshooting is normally done by some kind of an expert. I mean, I wouldn't just call my mail carrier to come in and investigate an equipment failure. They're not.
We're not going to call safety to troubleshoot an electrical breaker.
That's right. So I'm not going to have the safety guys come in and do that. So in general, what I usually see is the equipment experts do come in general, for equipment failures to go do troubleshooting. But they just, even those experts, if it's not something they're familiar with specifically, aren't sure what to look for. And that's where you were talking about is what data do I need to gather? Do I need to look at the history of this thing and where we procured it from, and what, all those kind of things. Operational issues sometimes are overlooked. How did we start the thing? How did we shut it down? Because the maintenance guys aren't the same guys that are operating it. So these are the issues we see a lot of times where it is an expert troubleshooting, but when they get beyond their direct level of knowledge, they're not sure where to go. They don't know what data to collect.
And because of that, they typically stay in the realm of, let's just get the equipment back up and running, rather than what allowed it to fail or what caused it to fail, which is a lot more of a step back. Because we can go replace bearings all day, and a lot of times that's what the expert does, because I've seen how this fails before. I can get this equipment back up and running immediately.
New
this
bearing.
bearing,
Yep.
boom. But then it goes down again for the same reason, because we didn't see that it was some issue elsewhere in the system.
Right.
And that kind of takes us into where a lot of that other pieces of evidence we need to gather. Like, okay, what does the software controls for that look like? Or, what constants did we put in the software? What does the vibration history look like? How did we install that bearing last time? Did we have to use any heat treatment, or did expansion and contraction?
Is it the right bearing, right?
Did we actually
things,
install
right?
the right bearing
Yeah,
itself?
yeah.
Did we install it in the right direction?
Did we install it with a hammer, and knock that thing right in there?
That fits.
The receipt inspections for when this bearing showed up on site, did we check it for any damage during shipping? All of these different issues can make a huge difference on what led the bearing to fail, what caused it to fail.
So as an investigator, I find that when we talk with equipment experts, there's two things you get out of them. One, they are pretty decent at coming to what broke. They'll help you get that pretty quickly.
Yep.
What we often struggle with is having this moment of, well, how did this occur? How could this physically happen? And the ways that those, different variables might come into play, or we have a lot of mysteries when it comes to equipment. I think back to somebody was asking us about an incident that they had where this bolt had fractured. And this was just, they had done the incident, and they were just having us check it over and see what they might have missed in their investigation. And they were looking at this bolt, and they had this, basically they were doing a lift, and one of the 4 bolts that was holding this lift broke.
Wow. Yep.
And this shackle bolt, the guy, they had it on the snap chart, shackle bolt broke. They had no evidence under it, because it's not something that investigator had any experience with. And you just go and look at it, well, it just broke.
Yep.
And an experienced person that knows, hey, I can look at this bolt and see this fracture pattern and see if it's fatigued, if
Brittle
it
fracture,
brittle fracture,
whatever it
ductile
is.
fracture, if there was something about it that made it more likely. Did we hit something? Was it fatigue is in, we've used the same shackle bolt for 1,000 lifts, and
Yep.
it's been this crack just slowly propagated. They wouldn't even recognize that they needed to collect that evidence. And so you have to kind of go, well, okay, we're going to troubleshoot this. Who's an expert we need to get for this type of problem?
Right.
And you might have to send that out to outside analysis.
Maybe. Yeah.
Those kind of things come up. And I know as an investigator, as soon as it leaves the building, it's like, well, I might get this back in a month.
Yeah.
And your boss is going to be breathing down your neck. You're like, well, here's all the other things. And now I have to remember to close this one loop. Those things can be pretty intimidating to investigators.
So just your troubleshooting, your process that you're going to follow, and just the steps you're going to follow, and the things you're going to look at, that can be a problem sometimes, where you have 3 different teams doing 3 different things, looking at things. Guy over here doing repairs, guy over here looking at the cooling water system, and then the third party guy doing the inspection on the fractured bolt. Where is all this collated, and how do you keep it all together in your head so that you can keep track of what's the next step? Where am I at? What have I eliminated? What other problems could it be? That's also a problem sometimes, just keeping that straight.
And that's one of the reasons why we build snap charts.
That's right.
and use that as it, because especially for equipment troubleshooting, a lot of times we have theories, and I just stick my theories right up there, and it's like, okay, I've got to keep track of this. Well, here's my note. I'm expecting it back on this date. I've made it a different color so it stands out, and I won't forget it.
Yep.
And I've got these 3 theories of it could have been the washer, it could have been installed wrong, it could have been, and I'll put those up there, and until we can cross them off by talking to the expert or by getting that analysis back, we are not going to eliminate that as a potential.
I found those snap charts can be, I think people skip or don't realize or recognize the power of that snap chart in just your evidence collection for equipment problems. We talk about it all the time for HSE issues and quality issues, but the building of that snap chart while you're doing the troubleshooting is a wonderful visual documentation tool. So you can see where I'm at, where do I still need to go, what things haven't I asked yet, what's the dates of expected completion. That can all be put on a snap chart. It's pretty powerful.
And it comes back to, and I know we had this conversation in a previous podcast, I think with maybe Mark and Marcus, or I don't remember who was in it, but we had one just talking about like how people can frequently waste time talking about something and not documenting it. And with equipment stuff, it's very much like, okay, these are the possible modes. Let's put them up here, and we'll cross them off as we get this information. Yeah. But not just chatting about it. Let's put the evidence on our Snapchat.
That's really important a lot of times for equipment troubleshooting, because it'll go over several shifts. It'll go to different people as they turn over to the next guy, and where am I at? You can waste an enormous amount of time trying to rediscover what the previous shift did.
Classic Tiger Team challenges.
Yep. So it's having that snap chart there as your documentation tool that follows the entire process.
Now embedded with the snap chart in TapRooT, we also teach Equifactor for equipment troubleshooting. How does that help a team that's trying to troubleshoot or trying to understand what happened in an equipment failure?
Yep. So that's kind of like on the root cause tree. There's a lot of questions that experts ask about human performance and equipment difficulties, but Equifactor is a more specific tool to help us build the snap chart. When I see this pump seize, what is everything all of our experts have ever seen or experienced that we need to look for? It's a tool that kind of takes that 30 or 40 years of an expert's knowledge and puts it right there. Here's what we need to look for, and there's nothing else. What is everything that can cause a pump to seize? Okay, let's go look at these 20 possible causes, maybe 6 of which apply, and it's a team. It keeps us really focused on what the actual issue is, because engineers is kind of their, as an engineer, kind of like, oh, there's thousands of different ways this can fail. There's all kinds of millions of pages out there on what this could possibly be on just seizures. But when you take all of that knowledge and all of that operator experience and distill it down to what do we actually need to look for in the real world, that list is pretty short. We need to go look for X number of things. We need to go look for grit in the mechanical seal or in the shaft. We need to look for loss of lubrication. We need to look for overheating, indications of overheating. And all of those things are specific pieces of evidence that we can go gather today. And we don't have to keep all this theory in our minds. All the theory is important, but when we go to a pump, it's seized for a reason, or
It's physics,
two or
right?
three reasons. Yeah, physical equipment obeys the laws of physics, and so we need to go find that cause, or maybe 3 or 4 causes, because these things kind of cascade.
Right.
That what led to this pump seizing, because that's the last thing in a chain of events usually. And all of that background information tells us, okay, maybe we're getting some vibration through our piping, and we can go identify that. Or maybe we have, we had to gronk that inlet piping over so the flange made it up. Or maybe there's some soft foot on the pump where it wasn't quite, kind of that chair that's one leg is shorter than the rest. It's kind of rocking back and forth. All of that experience that a 40-year operator kind of knows, or has at least seen it before, all that's right there, not just for the experts, but for those that don't know the difference between a pump and a compressor. These are the types of things we need to go look for. And now I just have a checklist of what I need to go gather, and I don't care about anything else.
And even those experts, a guy that, I had guys on the boat who I can still think of their names and see their faces, that are just terrific mechanics. And I'm thinking mechanics specifically, but it could be electricians, could be whoever. They're really good, but they're only as good as their experience level. So there's lots of things out there that even an experienced mechanic hasn't seen before and has never heard of, especially on a newer piece of equipment. So these Equifactor tables will probably cover 80% of what your experts already know. It's that last 20% that gets you stuck, and that's where those tables really show their usefulness.
And I think a lot of I'd say equipment training is really good at getting you to what you need to replace to get something operational. And part of that is you're in crisis mode until the equipment is operational again. Right. If it's shut down, we're not making money, or we're not making whatever.
You're hearing about it, right?
Yeah. So there's a crisis mode that people get put in, and to get it down to replace. But I think once it's replaced, there is very frequently, they drop the ball and say, okay, we've got it replaced, we're good.
Done.
And they don't go back and say, okay, this went down for a reason. Let's walk back through what happened and what can we do to prevent that from the future.
And some of that will be additional, like you were saying, a cascading problem. It could be additional mechanical or electrical issues, but it could also be, in parallel with that, the human performance piece of it, right? It could be a guy, like I said earlier, didn't start it up right, or shut it down right, or did the wrong maintenance on it. Those are all things that are, while it may seem at the end where the pump seized up that it was a mechanical or an equipment problem, it's actually people have their hands on it, and that can cause issues.
They installed it, they operated it, they maintained it.
Yep.
And so all of those you have to collect information
They
on.
bought it.
They
Right?
bought it.
They could have
yeah.
bought the wrong piece of equipment, right? That happens more often than I'd like to admit.
They substituted it and never did an MOC.
Yep.
There's a lot of those kind of things.
Yep.
So Equifactor, it's got pre-built tables that help people collect and know what to look for. You can make custom tables in it. And then if you don't have tables, and I think this is really where even a non-expert, if they just take the time to think through, there's failure modes and failure agents. And they're difficult at first. If I just told you, oh, you've got to look at, was there any deformation, displacement, a fracture, a surface material change? An HSE person might start getting their eyes. What is that? Well, okay, let's
Glaze over real fast.
Let's just did we hit it and it got bent? Okay, no. All right. Was it something that broke and you got 2 pieces of it? Okay, that's a fracture. We can look at that.
Is it all scratched up?
Is it all scratched up? Right. There's things like we can simplify what we're really thinking about and just look for oddities, because a lot of times in investigations, especially with equipment failures, you're trying to look for, when we call it change analysis, what was different, what changed. And so you're just looking at what is the normal thing and where's abnormal. I can remember an incident with a wheel that fell off, and people got really worked up with this wheel. This fell off, but they didn't have the information of what happened. But they knew a wheel fell off.
Yep.
And so they're focusing on, like, oh, it was the wheel. The wheel must have fallen off while they were doing this driving, and that must have caused the problem. And you're like, you don't know any of this. You just know a wheel fell off. There's a truck in a ditch and there's no wheel on it. Anything could have happened.
That's all we know. Right?
So it's like, oh, it could have slid down the hill, hit the rock, and the rock took the wheel off. It's not that the wheel fell off and it took them down the ditch.
Right.
So there's a little bit of you've got to kind of really work to mark out when things happened, find those facts. Things like those failure modes can help with that, because you can look and say, hey, was this a impact that pulled it off? Was this something else? If it's fatigue and the wheel fell off because this crack slowly formed and then it just broke off, well, that you can see evidence of that.
You can see all the threads on the studs all bent and disformed or misformed, and that could be because it's been the lug nuts not on tight, right? All those kinds of things.
Or they put it on, they gronked it down with a power wrench and it was way too tight.
Yeah, all kinds of things to look at, though. Just by, like you said, those failure modes and failure agents, you can say, all right, is there some kind of a deformation here? Let me go take a look and see what's deformed. So
yeah, and so capturing some of that evidence, it's tricky as investigators to know those questions. It's why we use Equifactor to help. Here's your list. We also give some guidance in things like templates, because once I find that it was this type of bearing failure, well, now I have a target and there's things I need to collect. I got to look at history. I've got to look at PMs, repairs. Oftentimes equipment gets repaired and reinstalled and immediately breaks because some mistake was made in that repair process. And so we got to collect those and follow that evidence wherever it leads and keep an open mind. And that's, again, it's difficult for equipment people to do that, because equipment people it's replaced, we're good, we're back operational. And as investigators, it's okay, that's where I'm glad we are. Now we can focus on collecting this history and tracking these threads down for investigations. Now, if we've got non-experts and experts working together, who's got the primary responsibility of tracking these threads down? Is there a best practice? Is it, should you have your equipment people trained in investigating, or should you just have independent people doing this? What's the best practice?
Yeah, I cringe a little when I hear we'll just have the HSE guy do some initial investigation, and because it, as I mentioned, you're not going to just have your mail carrier go out there and start doing investigations for you on equipment failures. So I'm okay with having if it's an HSE incident that you're working on, having that HSE guy trained to know that there was an Equifactor thing to do, but really that guy is not the right one to go too much further than that. He needs to then say, holy cow, I see deformed threads on those studs. Where's my equipment expert? And go get that expert, and that guy should really be trained in the rest of the TapRooT system and in the Equifactor piece.
So you'd think there's benefit to having your equipment people go through the full training so they can see the whole process.
I do. I think there's because we want those guys not just. I want the HSE guys to be thinking about, hey, this could be an equipment thing we need to go further on. But I also want those equipment guys to be thinking, hey, I found a bent stud. I wonder if there's a human performance problem here. And I need them both of those groups thinking the same way on that. And there's huge benefit to having them both cross-trained on those things.
Yeah, absolutely. If there's any kind of equipment issue on an investigation, you should have some type of equipment expert that knows here's the direction that those usually go. Right. So that it can just be properly and efficiently moved through. And
that's why they've got to have, we cover Equifactor in the 5-day, but a lot of people won't, they don't have the time to go to the full 5-day, which is why we have an Equifactor equipment specific course.
That's right.
Because they, as much as a HSE person loves an HSE example, an equipment person would like an equipment example. And so I think there's a benefit to having some focus on your own specific types of investigations. So it's really good if you've got a reliability group, if you've got equipment supervisors, maintenance supervisors, those kind of groups that are going to be leading those equipment investigations and reporting out probably to ops for equipment failure. This gives them a much more robust process. They can report day one, yes, we've got it replaced. here's where we're at in the investigation. This
Right.
is the evidence we need to collect.
Yeah.
And it gives a little bit of a better pace, because I know as operations, I always wanted the answer that moment. As soon as they replaced it, I wanted them to already know what happened.
Yeah.
But in reality,
Yeah.
they don't really know right away.
Yeah, it's not very often that actually comes up in the first 15 minutes. It takes some detective work to go figure that out. Yeah.
Well, this way of kind of cross-training engineers to deal with human issues, and the HSE reps and the non-technical roles to deal with some equipment failures, is that it's never a clean break of which one is which. The equipment side is designed by humans. It's operated by humans. It's installed by humans. It's maintained by humans. So there's a lot of human errors that can be made and are made all the times in equipment failures. And so, as an engineer, sometimes I just like to stay in the equipment side, but there's all those pesky humans that just interact with our equipment that we have to deal with, and we have to know what kind of questions do I need to ask about the maintenance and the actual installation and operations, because a lot of times that does lead to the equipment failure itself. And then when I have my HSE rep trained in some of the equipment side, they know what's going to be coming. They know what to look for. They can start using that even at home for some basic equipment failures around the house. And then they can start getting really proficient at doing the equipment investigation, so that when we see, hey, this turbine just went down, it's a huge safety issue. Maybe we threw some blades, out of the turbine because it became unbalanced. That's a huge safety issue, but there's equipment failures that led into there. So immediately, as I'm investigating this SIF or SIF potential, what's the direction that's going to go for the equipment failure? And I don't just leave it off there in equipment land, but we go attack it in a proactive investigation way.
And I think that's a big point too, because a lot of equipment failures are safety near misses that just no one was there to get hurt, or it just wasn't involved in a certain process that could have gotten someone hurt. So I think a lot of people don't recognize that they're dealing with a PSIF when they have an equipment failure, and they really should be treating it with a full investigation and not just replace it and move on with their life.
Yep.
One of the other elements in this reminds me of, I remember the very first in college reliability internship I did. The first plant I went to in that internship, I was walking with the colleague that I was with. He was the experienced guy, and I was the junior there going to help with an FMEA. And we were walking through the spare parts area, and he was pointing out, looking at the ways that things were stored, and just talking of the things that he looked for when he was doing these site visits. And he's like, oh, how it's stored makes a difference. How we receive it makes a difference. And I think that's also something that's commonly missed in investigations, is that they'll collect evidence for an operator used it wrong. We're pretty good at collecting that evidence.
Figure that out. Yeah.
Somebody used it wrong. They used this thing as a hammer, nail gun as a hammer, and they beat it in there. Okay, we can see when somebody used it wrong. But what we often don't look for is, oh, it was defective when we installed it, or oh, we kept it in this area that maybe it had open access to moisture, or it was stored vertically when it should have been horizontal, or hey, we didn't rotate this shaft periodically and it sat there for 10 years and seized on itself.
Yep.
There's things that people often frequently don't look at because they just didn't think of that as an opportunity. And so we've got to make sure that we're collecting not just the PM history, but also where this component, the history of where it traveled, whether it was inside the facility or, upon receipt. We were talking today, I think you mentioned, talking about if you've got something that you found a defect from an outside. What were you saying about that?
Yeah, sometimes when you have a defect that comes in from external, we often think to ourselves, it just came in, there's not much we can do about it. It came from the manufacturer that way. Go yell at the manufacturer. There's still things we can do. Receipt inspections are a prime example of that. We can do a receipt inspection as it shows up to our supply department. You can have policies in your supply department on critical equipment, how it's going to be stored. So it's really tempting to just say, yeah, our supplier screwed that up, and there, we wash our hands of it. Supplier, don't do that again, right? But I mean, that sounds nice, except it's our equipment that's breaking and it's our plant that's down. So if you really want to avoid that, you have to put other safeguards in place that avoid just leaving it up to the supplier to keep your plant up. And that's not how you want to operate your plant. So receipt inspections, storage locations, how when you procure it from your supply department, how does it get from the supply department to the plant? I mean, just the movement of it from one place to another. SpaceX has been having problems on their rockets with their carbon overwrap pressure vessels, COPVs. They blow up on the pad when they pressurize them. They're highly pressurized. They got carbon fiber wrapping over aluminum tanks. And they pressurize it, and it's done it twice now. They've blown up 2 ships on the test pad because these high-pressure cylinders have blown up. And what they're discovering is when it shows up from the manufacturer, they're just showing up. You can't ding a piece of carbon fiber, and it's still okay. So they're not being transported properly. They're not being stored properly. When they install them, they having mechanics in there standing on them, and they're not being done properly. So they have put a special test facility in place that when a new COPV shows up, it goes to the test facility and they test it behind a bunker and they test it. They fully pressurize it. I don't know what their numbers are. I'm assuming they'll go to 125% or something, whatever it is. And they verify this thing before they put it in the ship that's going to blow up on them. So that's a receipt inspection that they do. And they now know if it blows up after that, it was not due to supplier problem. That was internal transport, installation, and operation of the piece of equipment. So that's things you can do to, even though it's a supplier issue, there's still things you can do as an operator.
Yep, and then you've caught it before your plant has blown up.
That's right.
And if it does, if you do catch it by, hey, my critical process goes down or my ship blows up, it is well nigh impossible to go back and have the manufacturer fix that, because now my humans have put their hands on it, installed it, transported it from the receiving warehouse to the installation pad, and there's so many things that can go wrong there that it takes a lot more work to really prove that it's that manufacturer issue.
That's right. So if you test everything as soon as it comes in and it's good, it is no longer a manufacturer issue. Right? It is now mine. I own it.
And that makes it a lot easier to track down where are my processes,
That's right. Exactly.
Where do they need improvement, what's going on here that causes and leads to a failure.
They actually design special casings that they put on these as soon as they show up from the manufacturer now, so that as they're transporting it and they install them in the ship, they can then take that casing off once it's in. That protects that carbon fiber. So it's all pretty cool, but things that you can do to help avoid those kind of issues.
And I kind of our final topic, I would say, one of the other really difficult things when it comes to equipment investigations is the history. This part was installed 10 years ago. The person that installed it they're not here anymore.
Manufacturer's not even around.
Yeah, it's like this part it's a unique part. We don't even get them anymore. We've got 4 that are in inventory. That's it.
That's it. Yep.
There's those kind of things where there's MOCs, design, installation that was done really long time ago, and maybe we've done a decent job at repairing or maintaining that. But then you come across this weird use case. Oh, it wasn't designed for use with this chemical.
Right.
And we're like, well, where was the design originally for this? And they're like, we don't even have that document anymore. It was lost.
Yep.
That's also a tricky thing, is making sure that your history is accessible. And I've seen several equipment investigations where they're like, well, we don't have this information. And the mistake is to stop there and go, well, we don't have the information. Guess we're done.
Yeah.
Really, what we should be doing is saying, okay, we don't have the information this time. How will we get the information next time? What's the process we should change?
See, years ago it was hard because it was all hard copy handwriting stuff. That's not true anymore. CMMS systems are out there. They document all this stuff for you. You still have to do a lot of work. Don't get me wrong. It's not magic and it just happens. But it's much easier to properly document things now than it was 20 years ago, where you're keeping reams of paper and trying to read through stuff. That's gone. We don't do that anymore.
Yeah, if my program's pretty new, I might be able to go back and say, hey, we've done this many bearing replacements over the last 10 years that kind of had similar things there. But if I have a pretty good mature program that did good root cause analysis, hey, we've had this many lubrication issues that led to a bearing failure, and you can start getting a little more sophisticated like that. But at the end of the day, you can still go back and look at those bearing failures. If they were in a similar type of scenario, pretty good probable cause to say it may have been the same things that kept causing this failure again and again, especially if it's one of those repeat unplanned turnarounds for 3 or 4 in the last year. That's pretty painful. We got some motivation to do that.
And that's why you need good RCA for equipment failures, is so you actually have some data to trend.
That's right.
And it's not just, we have this department fails a lot, this component fails a lot. It's well, okay, what about this component failure? What do we really know?
The really painful ones are, hey, this was a tolerable failure, or this was a random statistical failure, or normal wear and tear.
I remember my reliability curves, and man, electronic components is basically random failure, and when it happens, it happens.
They don't wear; they just break, right?
It just breaks. It's the light. The light worked, and then it didn't the next day. The LED just didn't work.
Yep.
Those are tough. So if somebody's going to learn more about how to actually troubleshoot equipment failure and how to investigate equipment failure, what are their best options for training?
Yeah. So, Equifactor equipment troubleshooting course, you're going to learn how do we prove the mode or mechanism of failure, and how do we really dig into everything that humanity knows about equipment failures to prove this failure this time, what happened, all in the context of a human designed it, a human operated it, a human maintained it. And so how do we really get our minds wrapped around those pieces too? And all that's going to be in 2 or 3 days, depending on your course.
So Equifactor or?
Well, you've got the 5-day course, which introduces you to it. You can go to a 5-day, and I wouldn't necessarily think that's how you will want to complete your training. I think that's just a good introduction to the Equifactor piece, along with the rest of the human performance. Obviously,
it's going to get you the fundamentals for doing an equipment investigation. But if you want to be a true expert, you got to come to the full Equifactor course. Right. And a lot of people do at our summit. That's a great time to get that full Equifactor course. And get that training. And we have a track on equipment failure too. So
Absolutely.
There's a lot of opportunities for learning more. You can find the links down below for training, and we'll hopefully see you at the next Equifactor course or 5-day.